All right. First part's really hard. You got to tell me your name and what you do.
All right. I think we can do this. Uh, so I'm Aaron Slodov, the CEO and founder at Atomic Industries. And what we're trying to do is teach machines how to manufacture stuff here. And what we're focused on is honestly transferring a trade skill into an AI.
Okay.
And digitizing something like this is not a really straightforward process, right? Because this is something that humans do over the course of decades. And it's not something that you can just encode, right? Like text and images and then make a model and have people access it. So this is very similar to building a stack of technology that self-driving cars use.
Okay.
Right? Like this whole thing is a big system that we're trying to control ultimately. And in my mind, at least, if we want to have any hope at accelerating the pace of development in the industrial base, we have to be able to digitize trade skills to preserve them, replicate them, and then ultimately scale them rapidly. Because otherwise it just takes, 10, 20, 30 years to train a whole new workforce of people. And what we are doing here, right? This trade is called tool and die making. So this is the keystone to mass production. You have like a widget and you want to produce it in some volume consistently and reliably. You make a mold or some kind of tool. And going from the design of that widget to the actual manufacturing tool is what's locked up in everybody's head here. That's the trade skill that we're after.
Yeah. Well, it breaks down a little bit. Tool and die making, this is like step one to starting to manufacture things, right? And it's a skill that people spend decades learning, but in manufacturing terms, it's some of the hardest stuff you could do.
Yeah. I don't want to be a voice for, the entire manufacturing community, but I do think that tool makers are very well regarded, right? Because this is it's the pinnacle of how you actually catalyze production. So without being able to mass produce or make manufacturing tools, we can't mass produce anything.
So you're going to make it the thing that's going to make the thing. You make a mold, and that mold becomes the foundation of a bunch of car doors or airplane wing or whatever. And the idea is you're going to stamp out a whole bunch of them, but you have to make that original part for
100%. Yeah.
And that stuff, so that requires like skill training, knowing how to use all this stuff. And the part where you're looking to modernize it, how does that fit in?
So something that has happened over the course of the last 4 or 5 decades, right, with offshoring and globalization is decoupling the design and the engineering from the actual manufacturing, right? So everything used to be vertically integrated. You would have it all in one place.
Yeah, because they're in Detroit. Ford's the most famous example, right? Of
Right.
making every part of a car from the tires to the whole thing.
Yeah, so it's obviously really challenging to have an entire supply chain to be vertically integrated, right? Like you do have to rely on suppliers on some level, but when you're making all the constituent widgets and components that go into something that you're assembling, you have to kind of assess what actually makes sense to do myself, right? And the viability of that has just been like commoditized over time, right? In supply chains all over the world. So yeah, if it for some reason makes sense to take your design and ship it somewhere else and have them figure out how to make the mold and then like bang out parts, that's what we've been doing, right? So if you want to actually accelerate how quickly we can make physical products, recoupling that stuff back together and revisiting vertical integration is how you get faster cycle times, right? On being able to iterate on a physical product. So a lot of the times making one of these is a huge barrier to being able to make a new product, right? Like especially at scale. So what we're trying to do is put the design and the engineering and all of the trade knowledge, the tribal knowledge that goes into this right back into the production process, right? So like you want to keep it all very tight. You want to keep it coupled. And just like a self-driving car, right? Like you wouldn't just develop the software and then throw it into somebody else's car. I mean, there's a couple examples of this, but like comma, right? It's a device that you can put in some cars, not all cars.
Yeah.
Versus like what Tesla does, right? They're not selling their system to Toyota or something like that. So this is how I make analogies in my head.
Yeah.
Like all self-driving kind of stuff. But ultimately, keeping it tighter gives you faster iterative loops, basically. So when you talk to people about manufacturing, one of the kind of lower level problems is I've designed something, I've prototyped it, and you've heard Elon say this a lot, right? Like prototyping is easy, production is hard. This is a huge barrier to entering production. Not to mention just setting up an entire production line to do all the assembly and whatever else you need. But tooling something and making these molds or dies or whatever is a huge barrier. So
which part are you guys, when I look at the shop, I mean, there's machines from Portugal, Italy, Germany, Japan, and you've got these guys running them. Where does Atomic fit in? What are you adding on top of these machines then to bring stuff back to the US to modernize this field?
Yeah, so let's say that you have some widget that you now want to mass produce at some volume, and you need a mold to make it. Basically, where we're coming in is trying to figure out how to actually design and engineer that mold more rapidly than anybody on Earth, right? By taking the CAD file, and through the geometry, right? Like being able to figure out the construction of one of these things. So it's taking the same skill set that the tradespeople have and applying that on a kind of computational level, right? Because ultimately, the crazy thing about this trade is if you give me a widget and you took that to 100 different tool and die shops, they're all going to make a different design.
Okay.
Right? And the interesting thing about that is the actual function of the mold, once it's done, will be also completely different than anything else, because the distribution of efficiency and engineering that went into that just is a reflection of their skill and ultimately like the tools that they had. So when humans do this job, they basically have their tribal knowledge, they have CAD, and they have some simulation software to help them go from like your CAD design to a finished mold. And that time is limited because people need to like produce, right? So you're always going to be time limited in how many iterations you can actually go from the part file to the finished mold.
Yeah.
So what we want to do is cut that time down from weeks and months to hours.
So the idea is, I'm a car maker. I'm gonna head towards a new model. These molds take months, years to design and produce, and now you guys are gonna use software to speed this process. There's all this artistry, this craftsmanship that goes into knowing how to make the part, the file that the machine is eventually gonna have to produce.
Yep.
And so you guys are gonna try to use software to smooth out and speed up that process. And then I guess the hope being, if your software is good enough, then what? Then like people want to make stuff here, and it's easier to make stuff in the U.S. or
Right.
or it's easier to make it anywhere you have
This.
access to this. Yeah.
Yes. So basically, yeah, the idea is if you digitize this well, right, and let's just say for the sake of discussion, it's trained on knowing the control systems for like these machines that we have. So now it understands, once I've engineered a good design for a mold, I know how long it's going to take to cut on the 5 different CNC machines that I have and drill holes, or 3D print pieces of it, right? The production orchestration actually matters a lot. So yeah, I mean, basically, if you collapse that whole amount of engineering time down from like 1,000 or more human hours of engineering and labor per mold to like less than 100, or even less than that, right? You open up the aperture for what can be done, because ultimately this isn't a barrier anymore. And it ultimately comes down to the actual fabrication time. So like how physically fast can you cut the metal now, right? So we don't plan on necessarily, breaking physics and how fast you can machine like steel, but the designs that come out of the software might be more elegantly planned and more efficient for the operation. So yeah, I mean, it's Jevons paradox for physical goods. Like if you give people a better way to do it and open up that aperture, I at least think that people will make a lot more stuff, and it does give people more access to produce things wherever they want.
So we see all these machines around us, but then, you guys are fundamentally a software company at the core?
I mean, yeah, it's very similar to, right, like the same concept of what Elon did with Tesla or SpaceX, right? Like there's software at the core of everything that they do.
Yeah, it's a computer at the heart of it. And okay, so today, you guys have been going for what, 4 years?
About
4 years. What stage are you at? Is the idea that you like make parts for all other companies, or that they end up buying your software to run their own shop?
So the evolution of this thing has basically taken the form of starting with software only, right? We didn't have a factory when we started, and the idea was, can we actually prove that the software that we want to build can compete with tradespeedpeople that have decades of experience, right? So ultimately, the way that we approached this was, instead of speed running, building factories before we knew technology could help us scale something like this, we did the reverse. So we started with the software to understand whether or not we could even compete with human experts, right? And then the idea is build a factory around the core of that capability. And as that capability matures, right, like if you talk to anybody in industry, having a piece of software that can design a production grade mold for something it's literally insane.
Right.
They would basically tell you that it's probably fake. So, which is cool. But you have to be able to scale the factory around that capability. So you don't want like the design and the engineering to be a bottleneck ever again.
Yeah.
Right? Like the machines have to become the next bottleneck. So basically what we're doing is we evolved from software to this factory, which was applied software on the mold making level to show that the designs that our software created could be applied to real mold making. And then, like you mentioned, right, the next phase is starting to make parts using the molds that we make. So we're in the process right now of building another factory that's going to be basically just like a giant production facility.
So this is always like the prototype for the next factory.
This is kind of like the engine for that factory.
Okay.
It's kind of like launching rockets, right?
Yeah.
Like every mold that you engineer gets launched into a production site where it's just pumping out parts.
Where's that one going to be?
It'll be close to here,
Okay.
like within 10 miles.
Okay.
Yeah.
Okay, and so let's make it like some of this knowledge is all stored in your head. I mean, for somebody who's never dealt with molds or anything, I mean,
Yeah.
when you're saying this is like complicated and a year-long process, I mean, pick apart and walk me through what it would usually look like.
Yeah. I mean, we can use some kind of automotive part, right? Like the mirror or a headlight or something. So a headlight's probably too complicated, but a mirror is still an assembly of probably, I don't know, a half a dozen parts. So if you took the mirror off your car and unscrewed it and looked at all the individual parts, every one of those will come out of a mold if it's a plastic widget of some kind, right? So in the beginning, somebody basically prototyped that whole car. They designed it. And what happens during the design process is like a continuous engineering phase where they're taking each individual component and they're trying to understand, right? Like there's a Gantt chart of production. So every component in that car is ultimately going to be shipped from like a tier 1 supplier or a tier 2 or somebody like that, right? With the exception of the really highly exotic non-commodity parts that they have to make in-house. So that Gantt chart is like filling up, right? Like there's hundreds and hundreds of parts in a car that have custom tooling made for them every new car launch. So a fact that I think is really interesting is every new car model, probably for the last 10 years at least, maybe 20, there's like at least $1 billion of tooling that's required for every component that goes. Some of it's standardized, right? That they can reuse over models, but when you design something new, you're taking a snapshot of your design. And that's what ultimately goes into these molds, right? Like they're capturing snapshots of every design decision and intent. And ultimately what ends up happening is that continuous process, they're going back and forth with the manufacturing team because product designers don't understand how all this works. What they have is they have standards and heuristics, right? Where it's like, don't make something with this angle or like a feature that we know cannot be molded, right? So there's a lot of guardrails in design to make things more easy to mass produce.
Yeah.
So if you have this constant battle up front between wanting to design something really cool and the manufacturability, right? So if you've ever heard the term like DFM, that's design for manufacturability.
Yeah.
So you kind of want to, what's happening up here is a balance of designing cool stuff, but also trying to make sure that it can flow through a factory.
It actually
right?
made,
Yeah. So that process is insane because it takes weeks and weeks of just, design and mechanical engineers going back and forth with manufacturers, right?
Yeah.
And they're trying to figure out the feasibility of their design.
Yeah.
And then once all those design reviews are done and stamped off on, then they get shipped to the suppliers, right, to start building the tooling for it. So there's this huge phase of like feasibility, and this is automotive, right? Like it's different for every industry.
Yeah.
So if it's like consumer goods, it doesn't matter if it's like apparel, electronics, right? Like CPG stuff that, whatever, like packaged goods, there's still a similar process like that happening. But ultimately, this is what happens when you disconnect design from manufacturing.
Yeah.
Is you have to have this like huge cat fight up front. Yeah.
The different teams. Yeah. This is part of this many-month, year-long battle is that the design team wants certain things. The manufacturing people can only do it a certain way. The people who work with these machines know all the little nuances to get these things out. And you guys are trying to build software that the designer sends their hopes and dreams, and your software can translate that into something that can actually be made much more quickly. Is that the right idea?
Yeah, I mean, ultimately, you want to kind of eliminate that upfront catfight that happens, right? And it's really interesting because if you've done any type of other manufacturing, like 3D printing, right? Like we've invented so many technologies to avoid having to make molds or do tool and die making for something because it takes so long and it's so costly. So we've invented all these other ways of making parts without doing this. So we're kind of just like revisiting something that's 100 years old, but we're, trying to just modernize it. But yeah, ultimately what the software can do is if it can actually look at a part geometry and construct a production ready mold, what you're doing essentially is eliminating that by, you could essentially just live in their CAD software while they're designing something and give them feedback, right? Like, oh, that angle is like too steep, or that feature that you put in there, that's obviously not moldable, right? Like, so there's some guardrails that the software could go upstream to the actual design of the part to help people just make that flow through way faster. And then, ultimately, it just becomes a matter of how much open throughput or bandwidth we have to make that mold and then shoot it into production.
Okay.
So, yeah, in my brain, it's kind of like a data center almost, right? Yeah. It's like the ability to design and build molds, and then ultimately the capacity you have to make parts is like your computing power. It's like how strong are your GPUs or whatever, right? And it's like, how many GPUs do you have? So ultimately, I kind of imagine this as just, cloud computing, but you're just trying to make parts for people ultimately.
You know, I see you on X all the time. You know, you're celebrating American manufacturing, and obviously you put this company in Detroit for logistical, but also I think some symbolic reasons. But like, if you have this software that figures this out, doesn't it just end up getting used in China and Vietnam and different places where we're already making things? Like, how, just because we have better software all of a sudden, why would we start making stuff here again?
So this is kind of like, this is my answer to doing this stuff viably, you know, domestically or wherever you choose, really, right? There's a philosophical angle to this, which is that manufacturing in many ways is just a race to the bottom. And like true abundance is near zero production cost, ultimately, right? Like you want stuff that's like really cheap. What we've been doing over the last 60 years is exploiting labor costs and subsidies that governments are willing to give, right? So we turned China into the factory of the world. Some people think that that's cool and okay because like it lifted many millions of people out of poverty, right? Like this is a cycle of industrialization that nations will go through. Personally, I don't find it too tenable to, you know, make somebody work in a dirty, dark, dangerous factory for my socks just so I can have $5 socks, right? Or like $100 television. I mean, yeah, it's great, but ultimately nobody cares about these people working in the factories, right? So I think that a lot of the idea behind this concept and like teaching machines how to make molds to make things moves us in a direction where we can, you know, automate a lot of this stuff, or it just becomes more of like an engineering task rather than something where you're, you know, working in a factory for 18 hours a day, right? Like just hitting a lever all day long. But ultimately, I do think that the reason that we built the company here, right? Like this skill is not available in the level of concentration it is in this zip code anywhere else in the United States. So, right, like the industrial DNA of Detroit and all the tool making history and families that came up here are still kind of a residue here, right? Like it's still needed, even though we've outsourced a lot of it. But this is kind of my thing, right? Like I want to capture what's left of it and then regrow it. I'm not trying to get rid of these people or replace them. I'm trying to turn them into superhumans, basically. And ultimately, the software just acts kind of like a DRM level, right, on the process. So you can kind of go back to that self-driving car analogy. Like the software will not be able to just be applied to any shop anywhere in the world with any machines in it. It's going to be kind of a fixed product of the machines it's attached to here.
Yeah.
Like, yeah, again, going back to like the self-driving car thing, right? Like you have to drive the millions of miles to learn. So a CNC machine is a CNC machine is a CNC machine, but not really, because there's still nuance to the control systems and how it ultimately goes from a design to actually cutting the piece of metal. So there's like, maybe in the future, the software could proliferate like that, but ultimately it will need to be like a vertically integrated package. Yeah.
I mean, as part of my trip to Detroit, we're going to go to this Re-Industrialize conference. I think this is the second year of the conference. And so you started this thing last year. And what is it, man? It's like it's like this. I mean, it's turned into a thing. It's like this annual gathering now of people who make stuff in the U.S. and want to come talk about all that.
Yeah, I mean, I think it really struck a very interesting, you know, nerve or chord last year because on a macro level, I think for a while people believed that globalization was a very good and harmonious thing, and you know,
the world is flat. Tom Friedman, man.
Well,
mustache of understanding.
Right. I think what we're ultimately learning in a more pragmatic way, right, is that being a more interconnected and intertwined economy that relies on the production of goods in other places that are ideologically opposed to us is a challenge. And it's not something that is tenable ultimately, right? Like for the philosophical reasons I gave earlier, but also now we have a lot of people trying to sound an alarm, right? Saying, if we can't make these things domestically, that's kind of a problem, right? Especially if on our doorstep, there's somebody who can outproduce us in almost everything, right? So that's scary in a lot of ways. And even on a technological basis, right? Like industrial power is the basis of all other power, financial or otherwise. Military power, it all comes from your industrial base. People like to separate these things like they're separate, but they're not. In my mind, it's just like you either have the skill and the people to execute on that stuff, along with like the capacity, right? Like the factories and the machines, or you don't. And so as our skill base has evaporated, we're just losing the ability to like make things. And Reindustrialize is kind of like a revival of this concept, right? Like, why are we giving that up? Why did we give it up? You know, I think the orthodoxy that allowed us to get to this point was all fair and good, right? Like up until now, people are just not okay with it anymore. Yeah. So what is the answer to that? You can't go back and erase 50 years of globalization in a year. That would be like that's like 100 Operation Warp Speeds, but for manufacturing. Yeah. You would need trillions of dollars, right? And like massive skill transfer programs and jobs. It would be insane. So if we want to kickstart this, right? In my mind, at least, the most interesting way to do this is finding a marriage that historically has never really existed, which is technology and manufacturing coming together, right? In a way where we can actually accelerate how quickly we modernize the industrial base. And I mean, like, obviously the Industrial Revolution happened, right? And like we've seen Tesla stand up and do things domestically here, like Starlink factory and building spaceships, while other companies kind of stagnate, right? Yeah. To change. But I think that this stuff is possible, and people are kind of showing us, right, that this is actually a viable business again here when you actually use modern technology. So the question is, who's building these things? How are they going about doing it, right? Like, who's funding it? And how important really is it to everybody? And so, yeah, Reindustrialize is just trying to be a convening place and moment where everybody that's interested in that marriage can learn from each other, can, come together, and ultimately, I hope becomes an accelerant to moving the industrial base into the 21st century.
Tell me what Reindustrialize is and some of the history behind it.
So Reindustrialize is becoming, I guess, right, like the annual convening for the revival of the American industrial base.
And you started it.
Yes. I mean, I'm a guy on Twitter that thought it would be a good idea, right, to bring together all of these people across, government, military, finance, tech, industry, manufacturing, because I've just had the same conversation 500 times. Yeah. And I want to have it in one spot, and I want all those people to learn from each other. And yeah.
Is it a lot bigger? I didn't go last year.
Last year was about 800 people.
Okay.
And we still had a few thousand on a wait list trying to get in, but we hand select every single person basically. And we did the same thing this year too. Okay. So this year will probably be about 1,000.
I see people on X freaking out. I mean, it's like it's a hot ticket, man. I think I'm supposed to interview Palmer Luckey as he's going to be an Android form or something like that.
Yeah. This should be. Is that going to be the first one of these? I don't think I've seen a high profile humanoid.
I don't even fully understand what this is supposed to look like. Yeah. So I feel like it's new.
Yeah, he's going to be giving a keynote speech as a humanoid. So yeah, it'll be
No,
cool.
he's talking to me.
And you.
Yeah. I don't know if there's a speech. Yeah.
It'll be cool.
It'll be interesting. Okay. Tell me about your background. Are you from Detroit?
I'm from Cleveland.
You're from
originally.
Cleveland. All right. So you're nearby. You're almost local.
Midwest boy. Yeah.
Yeah. Cleveland. At least it's not Detroit.
We're friendly here. Yeah. My background is I have a weird fusion, right? So like I grew up in Cleveland, and ultimately, my training is in physics and engineering. I just have a really weird, unorthodox kind of path because I didn't go to school after high school. I like monkeyed around for a few years.
You were homeschooled in high school? Or?
No. I mean, like I did high school, but after high school, I did a bunch of weird jobs and stuff. Like I didn't want to go to college yet. I knew I wasn't like mature enough or ready, and I had had some really interesting exploration. Like went through a bunch of different like religions, and then ultimately came to the conclusion that like physics would be the best way to explore the universe. So I was like an abysmal student in high school, and ultimately like I had to teach myself, high level math and stuff to like just to even get into the physics program. And then I found it to be a really wonderful kind of exercise. And
so you went on a religious hunt and you settled on the religion of physics.
Yeah, and I was also just working a bunch of weird I worked at a pizza place doing pizza delivery, like landscaping. I worked at a law firm. I did a lot of really weird, odd jobs, and then like figuring it out along the way. But ultimately, once I got into, I went to like Kent State. I went to a state school, and it was awesome. I mean, just like worked my way through and was still working like 2 or 3 jobs. So it took me, 6 years to finish my undergrad degree. But ultimately, I was kind of at a point where I was interested in like high energy physics as a grad student, or going to get a job somewhere. And I only applied to one job after I finished, and it was at Google, and I somehow got it. And so I just decided to put grad school off and then went out to the West Coast, and I worked out there, was on all kinds of goofy, weird teams. Like I got to work on renewable energy and the self-driving car team before it was Waymo. And kind of like bopped around in a bunch of different, it was enlightening, right? Like getting to work at the bleeding edge of technology. This was in, 2010. And I got a really interesting glimpse, right? Coming from this world and like crawling my way out of the Midwest, straight into like high technology. And it was super interesting.
So Google still felt okay about R&D.
Right, yeah. Very interesting. But ultimately, I kind of like had my time there and decided that I ultimately wanted to go back to school. So I had worked at like a couple other tech companies after that, and then tried to go back for a PhD, and went back to Cleveland ultimately and started at Case Western and worked on power systems engineering. So I was always very interested in these kind of like more Lindy things, right? That were like, nobody cares about the electrical grid or the infrastructure, but it's dilapidated. And so I thought it'd be really cool to go into an engineering field where that's obviously going to be a concern in the future, especially as we kind of like build more energy, right? And need to modernize the grid. So I worked on that. And then during my PhD, I got sucked up into some other thing, working on my first startup company with a buddy from my undergrad days, and ultimately like just bailed on my PhD program to work on that company. So I'm just kind of like a moth chasing, interesting, really cool problems. And we built that company up, and I spent about 5 years on it, and then left after we built it up to a pretty good clip, got a bunch of funding.
What was it called?
Remesh.
Okay.
And the idea of that company was just like, he had figured out a really novel way using math from physics to take a huge, inordinate amount of like noise on social media and like boil it down to signal with a really interesting gamified, like real-time method. So you could basically have these conversations with like 100,000 people or more in real time. And it'd be like you're just texting a huge group of people. But we found a really novel way to do that. So it ended up just being really valuable for market research. So the company turned into kind of like a market research thing. Yeah.
Wait, how does somebody with this semi-disjointed background end up hitting up on this idea?
Right. So this was like after that company, I wanted to just step back from like, tech and startups and everything and do something a little more chill for a little bit. And this was a passion project. Because I don't know if you can tell, but I'm a giant dork. And something that I have always done was like played Dungeons and Dragons and like tabletop games. And there's like little figurines that go along with these things. Like it's like your monster, your character, or whatever. Yeah.
Yes.
So I wanted to make those. And I thought it'd be a cool side project, just to like try to start making these things. And I figured out the hard way real fast, right? Like how the kind of like legacy companies that make those do it. And I tried 3D printing and some other stuff.
Because you get 3D prints, you can get the plastic molds with resin.
Yeah. There are a lot of like lo-fi ways of making those things, but ultimately, if you know what these things are, right? Like they're hobbyist items, so they have to be high quality. People pay a lot of money for them, and they like paint them. They have huge collections of them. So there's this Venn diagram of like being able to make different variations of them quickly enough, but also be, high quality and low enough price, and that requires making molds, right? So
all this started from you wanting to get a mold for D&D characters?
Yeah. Basically. So I learned the hard way, right? And then I think what ended up happening was a bunch of my friends that were still out on the West Coast that worked on all these like exotic hardware teams, like in Apple and Facebook and Google, they were just like, yeah, go to China, right? Like find a supplier on Alibaba or something, and you give them your money, and then a couple months later, your stuff shows up in a shipping container, and it's like this magic API for crap, basically. Like, in everybody's mind, China is just like this API for stuff. And I was like, what? So I tried that for a while, and it was just a horrible experience, regardless of what you hear on, social media. But yeah, it didn't go so smoothly for me. And then I tried to find domestic suppliers to do this, and they don't care, right? Because it's just not like high enough margin stuff for them to do. So I got stuck in this really weird place where I'm like trying to make a lot of these things and make them high quality. You got to make these molds. But the barrier was just like very high, and it just blew my mind that nobody had really tried to address, trying to fix this problem. Like why aren't we know that this is the most efficient form of mass production. Like on a cost curve, nothing in the world will ever beat this, right? Like you take a snapshot of a thing, you make the mold, it sits in a factory, now it's making thousands or millions of a widget. Nothing beats that. So I'm like, why has nobody tried to innovate on this like 100-year-old process, right?
And just modernize it, make it simpler.
And then I found out that it's just the hardest problem imaginable, right? Because it's not something that exists in like engineering textbooks. It's a trade. And
knowledge is like passed down
this is
through practice and generations.
Yeah. And I learned the real hard way, just like, this is what it means to actually have a functional industrial base, right? And like people doing this stuff. If you don't have this, you don't make anything.
Okay. And I always want to make this super clear to people.
Yes.
And it's hard to do, right? So like when you talk about tools and dies and molds and how hard it is, like in my head, I want to make a door for a car. I know what a door for a car kind of looks like. Even if I'm making a new model of that car, I'm on my computer making my CAD drawing of it. And then, in my head, it's just like, oh, and now you send it to the computerized machine, that then creates a mold of that thing. How hard can that actually be? We've done this for decades.
Yeah.
Surely we've figured this out.
It is. I mean, it is a solved problem, right? Like we know how to make molds and dies for things, but what we don't know how to do is to commoditize this, right? Like it's not an easy process.
So what I outlined is doable, and we know how to do it. It just takes a long time,
Very hard,
and a
yeah.
lot of money, just because you have to do all these little steps to make sure that what's in your head actually comes out
Right.
on the other side. And you guys are trying to make software that looks at what's in my head and does a ton of the analysis needed to get this, to cut out all these layers in
Yeah.
between.
Yep.
Okay. And how do you build something like that? You started this really before like the massive AI takeoff happens. But I know that's kind of part of this. So yeah, do you have to show this a million parts and that's how it learns, or how do you do this?
Yeah, it's from a technology perspective, it is not easy, right? Because you do have to go through the motions of ultimately creating a new data set. Because even if somebody dropped off like on our doorstep the last 100 years of this type of work on a thumb drive or something, that's a good data source, obviously, but it's still tainted with what I went back to earlier with like 100 shops doing the same mold for you. They're all going to come out differently because everybody has different varying skill levels and machines and whatever, right? So the distribution is probably very normal looking ultimately when you want to look at like, did that mold, produce stuff efficiently, and was it super expensive, and how long did it take? If you boil all that down, ultimately what you're going to find is when we approach this problem, that kind of just like it's collapsed, right? Because democratizing a process is what is more interesting to me. And building something out like this is ultimately, you need to capture every stage, right? This is not a language model. We're, trying to do first principles kind of architecture here. So when you have a certain shape and we know the rules of like how it should move, right? Or like be machined, you can bake in some of these heuristics. But ultimately the data set that you're trying to curate and teach the machine is, how do I go from a shape to the mold construction, and then how is it going to function in the factory? So we basically have to feed all of that data from the cutting of every piece of the mold, and once it's put together, the parts that come out back into the software. That's like the self-driving car too.
That's what you're doing here with these machines?
Yeah.
Okay, so you're building the software, you're building the part, you're doing this loop.
Yeah.
Okay.
It's analogous to what somebody in the trade is going to learn over the course of 20 years,
I see.
right? Like a lot of times, because the design is, every different like skill pool that you have, like the guys running the CNC machines, they're not designing the molds. They're actually just converting the design
Right.
into something that runs on their CNC machine, and then they execute.
Yeah.
And then somebody else actually puts the mold together. So we're trying to like combine all of that
Okay.
into one core piece of software that can collapse that process down.
So you've been doing that here. You're going to open a larger facility, and that's like next year?
It'll be this year.
This year.
Yeah.
And then, so that's the next stage for the company.
Yep.
And then the goal is to like start pumping out parts for people. What
Yes.
would be like the first type of parts that come out?
So we're just starting to move into this right now, right? And we've got our first couple large contracts for customers.
You can tell us.
So one of them is kind of an automotive part, and it's pretty interesting because it was something traditionally that was made out of metal, and because of like the process that we have and the way we're able to work with this customer, we lowered the barrier, right, for them to be able to make it out of a plastic material. And so that's another really interesting thing, right, is like, yeah, there's a big market of stuff that can be made out of plastic, but there's another huge market of stuff that people normally wouldn't make a mold for it because it's just too costly. So we gave them a really interesting opportunity, right, to do a material change and then ultimately produce the widget for them. So that'll be, ramping this year. And then we're doing something that goes into the New York City subway system. It's like a little support structure that sits under the third
Rat.
It's a rat catcher. No, it sits under the third rail, and it's made out of a material that, if it ever catches on fire, it doesn't smoke, because apparently it's been a big issue, I guess. Like the smoke and inhalation, people are trying to eliminate that so nobody, dies inside of a subway from chemicals and stuff like that. So, I mean, the world is kind of our oyster, I guess, because there's, hundreds of billions of dollars of widgets to make, and we're just getting started right now. So,
Great. Well, I know you guys had to shut all your machines off so we could do this interview, and I was warned that there's a part sitting in a giant 3D printer over there, and that the metal is expanding while the air compressor is turned off. So I think we should probably wrap this up.
we could, yeah.
So that I don't want to be held responsible.
It's okay, yeah.
Okay.